First question, a point charge plus Q is placed at a distance d from an isolated conducting plate. The field at point P on the other side of the plane is. So if a point charge is placed near an isolated conducting plane, free electrons are attracted towards the positive charge. Result of this, some negative charge develops on the surface of the plane towards the positive charge side, and an equal positive charge develops on the opposite side of the plane. The electric field lines are away from positive enclosed surface or enclosed charge and perpendicular to the surface. Hence, the point and the field at point P on the other side of the plane is directed perpendicular to the plane and away from the plane. Hence, option A is correct. That is directed perpendicular to the plane and is away from the plane. So, option A is the correct answer. Looking towards the next question. A hemisphere is uniformly charged positive. The charge electric field at a point on a diameter away from the center is directed. So we know we have the question says there is one positive charge particle and there is an electric field present. Okay, the surface is given name A and B, and this hemisphere will have an effect in form of a hemisphere. Okay, so in case of uniformly positive charged hemisphere, if a point situated at a point on a diameter away from the center, the electric field should be perpendicular to the diameter. In this case, the component of electric field intensity parallel to the diameter cancel out. So correct answer for this question is perpendicular to the diameter. Option A. Looking towards the next question. 5 charges, that is Q1, Q2, Q3, Q4 and Q5 are fixed at their positions as shown in figure S. In a Gaussian surface, the Gauss law is given by which of the following statement? Okay, Gauss law is given by this. Okay, which of the following statement is correct? Now there is a diagram which is something like this. There are charges Q1, Q2 is over here, then there is Q3, Q4 and Q5. Okay, now we're supposed to look which statement is correct. So first of all, according to Gauss law, that is this law, the term on the right side of the equation includes sum of all the charges enclosed by a surface called Gaussian surface. In the left side equation, the electric field, that is this, electric field is due to all the charges present both inside here as well as outside the Gaussian surface. Hence, in the equation, E on LHS of the above equation will have a contribution from all charges, while Q on RHS will have contribution from Q2, that is the surface one, Q2 and Q4 only. Hence, option B is correct. That is, E on the LHS of the above equation will have a contribution from all the charges, while Q on the RHS will have contribution only from Q2 and Q4. That is only on the surface charges. So correct answer is option D. Looking towards the next question. The electric flux through the surface. Okay. So according to the Gauss law of electrostatics, total electric flux out of a closed surface is equal to the charge enclosed divided by permittivity. That is, this is the formula. Flux is equals to Q enclosed, the whole upon epsilon naught, that is permittivity. Thus, electric flux through a surface does not depend on the shape, size, or area of a surface, but it depends on the amount of charge enclosed by the surface. In given figures, the charge enclosed are same. That means the electric flux through all the surfaces should be same. Hence, option D is correct. That is, it is same for all the figures. Option D. Looking towards the last question. This figure shows electric field lines in which an electric dipole P is placed as shown. Which of the following statement is correct? Now, if the lines of forces are equidistant and parallel to each other, exactly parallel, okay, like this, the field is uniform, and if either lines of force are not equidistant or a straight or both, the field will be non-uniform, like here in this case. The number of electric fields passing per unit area is proportional to the strength of electric field. For example, see the following figure here, this and this. Hence, in given question from given pattern of electric field lines, it is clear that the strength of electric field decreases from left to right. As a result, force on the charges also decreases from left to right. Here in the given figure, the charge on minus Q, that is this, is greater than the force on charge plus Q. In turn, dipole will experience a force towards left. Hence, option C is correct. The dipole will experience a force towards left. Option C.